Now, we also have vertical work. Okay, so we've been talking a lot about things moving horizontally, left and right, but the reality is a lot of times we just pick things up. Okay, so you grab this and you pick it up. All right, well, I just did vertical work on this eraser. All right, it's something simple, but there's vertical work done on that eraser. Okay, so in terms of what does the vertical work depend on, we know a little bit more about vertical because we know the acceleration of gravity, okay? And we know that we're fighting against this force of gravity, okay? So what does that force of vertical work depend on? Well, it's the force it takes to lift the object, okay? Right? And what's your displacement going to be? Well, we could replace displacement with height. So basically, it's the force it takes to lift it up, and how high do we lift it, okay? Putting those two things together, we can say that work, a little rearranging or rewriting of our equation, is just the force that we're fighting of gravity, right? Because that's the force we need to lift something, is we need to fight against gravity, times the height that we move it, all right? It's no different mathematically, but now we know what that force is because we had to always oppose gravity in terms of gravity pulls us down. Now, force of gravity is our weight. So our weight is mass times little g. So we often use the one that I'm circling right now, the one on the right, that work is mass times the acceleration of gravity times the height. Because to be honest, it's really easy for us to find the mass of objects. It's really easy for us to measure the height of objects. And because we know the gravitational attraction, we know the acceleration that results from that, or little g. So now this equation becomes very useful for us, right? Let's take a look at this problem. How much work is needed to lift this car 0.45 meters, okay? So imagine we started here and then we lifted it to here, all right? So our displacement is 0.45 meters. We know the mass of the car, and we know that we're doing vertical work. So if we know the height that we lifted, we know the mass of the car, we should be able to solve for the work knowing the acceleration of gravity, okay? So go ahead and plug that in your calculator, pause the video, and once you have an answer, hit play and then see if you get the right answer. Okay, so now let's take a look at what we did. So our work is mgh. We took the mass of the object times the acceleration due to gravity, and since we're opposing gravity, it becomes positive because we're moving it upwards. So we have the force in the same direction as the movement. Our height was 0.45, so we get a work of 8.82 joules, or Newton meters of work on our object. Okay? Now, a lot of times when we look at this idea of work, people think that we can use ramps or inclined planes or things like that to diminish the work that's needed to be done. Okay, so it's less work if you use a ramp, or it's less work if you put a board there and roll it up the ramp to get into something. Okay, so let's look at this idea of, is there really less work going on if we use a ramp system? All right. Now, from our previous slide, we already know that if we're going to lift this car, 0.45 meters, we've already solved that it's going to be 8.82 joules of work. So to lift it straight up was 8.82 joules of work, or 8.82 Newton meters of work to lift it to the top. Okay, so let's take a look at what happens as we start to roll the ramp up to a 30 degree, 45 degree, or a 60 degree inclined plane. All right, so we go here and we start to move this thing up. And if we keep moving it up, if you look, as we go, the displacement here is different for everything. The forces are different, but in all three scenarios, on any point in the process, every time we move it further up, the work is the same. Okay? So we keep going up to the top, and once we hit that 0.45 meters, okay, if we look, our work is 8.82, our work is 8.82, our work is 8.82, okay? What is different is not the work, okay? So it's not less work to use a ramp system, okay? A ramp system instead requires less force, okay? Think about it. Why are we using a ramp? Well, it's because it's too heavy for us, right? If you want to lift something up, if we roll it up a ramp instead, the idea of a ramp is it makes it easier for us to push. That's the force side of things. So it takes less force to use a less angled ramp here versus a steeper ramp here and here. and if you hold it straight up, okay? So the idea or the take home from this slide is that when we use things like ramps and those kind of things, the overall work is the same because our overall displacement vertically, okay, is the same. However, the displacement along the ramp gets longer. So we have a lot longer displacement here, but less force. So less force because we rolled it up a longer part of the ramp, okay? So what we can say is that ramps reduce force, but at the cost of displacement, but the work is the same, all right? So that's kind of the take home here, is that we do not change the amount of work. We're able to lessen the force because we roll it along a further displacement along that ramp to get to the same height, okay? So that's one idea. Now, here's a quick little slide on some vertical work for you. If you notice here, they have, I think, 1, 2, 3, 4, 5, 6, 7, 8 different fire trucks hooked up to this car, and they fire up all the hoses at one time. And it's, well, it's way more than 8 if you take a look at all these nozzles. So pretty cool that there's enough pressure from each one of those hoses to create enough vertical work to do this. You know, they have guys on guidelines here to stabilize it and hold the hoses and that kind of stuff. But it's kind of a pretty impressive feat just using pressurized water to actually get something to do that. Now, we're going to turn it off and it comes crashing down pretty good at that point. But that's some vertical work for you. Here's another example one. All right. What's the mass now of a barrel lifted 3.5 meters by Donkey Kong if the work done is 1,550 joules? Okay. So once again, go back to your equations. Now they're lifting this time, so we want to go vertical here. And let's solve it, pause the video, and we'll get your answer. All right, so let's take a look at our answer. In this case, we're going to go vertical work, so we're going to use MGH. We want to solve for the mass, so I rearrange it, but getting mass by itself. And now I plug my numbers in. My work is 1550. I got my acceleration due to gravity. Again, we make it positive because we are opposing the gravitational force, so we're lifting it up instead of moving it down. And our displacement or our height is 3.5 meters, so we get a mass of 45.1 kilograms if you put that in. Okay? All right, guys, we're going to end the video there. In our next segment, we'll do energy. Thank you.